Okay, in this video, I'm going to go over how you apply the ANSI classes of fit to the diameter of a hole and the diameter of a shaft. Okay, so given a design size of 1.5138 inches diameter and a requirement of a class 3 fit and basic hole system, determine the manufacturing specifications for the following. The hole in unilateral tolerances with 4 decimal places, the shaft in unilateral tolerances, the minimum clearance, and the maximum clearance. Okay, so I'm just going to look at this problem and take away the important stuff from it and write it in a given table right here. Okay, so we know that there's a design size of 1.5138 inches, and I know that I'm working in imperial, so I'm just going to drop all units from now on. There's a requirement of a class 3 fit right here, so that's a good thing to record. And also we're going to use the basic hole system. So basic hole system. And I'm just going to copy in an image of what that means. So this is an image of the basic hole system. Now, what this means is the hole, you can see the hole diameter doesn't change here, depending on whether it's a clearance, a transition, or an interference fit. The shaft changes in diameter relative to the hole, in a clearance, transition, or interference fit. So maybe we'll just abbreviate our thoughts here. So the hole remains the basic size. And the allowance is applied to the shaft. Okay, so now that we have all this information highlighted, we have a pretty clear roadmap of how to start answering questions A to D. So I'm also going to use these tables here. Here's ANSI recommended allowances and tolerances highlighted in the DeGarmo text. So we know that it's a class 3 fit. And we're going to use these tolerances here, or allowance for the shaft, and these hole and shaft tolerances. So, if we think about the diameter of the shaft from the basic size, we know that the allowance is going to be negatively applied to the shaft. So we're going to have a design size, and we're going to create a gap in between the hole and the shaft by reducing the size of the shaft right here in this case. So that's how that is applied. Okay, so we also have basic sizes here. So I know that we have a design size of 1.5138. I'm just going to, from now on, use this table here to the closest value that I see, and that's 1.5. And so I'm going to use 1.5000 basic size from now on. Okay, so let's figure out the solution here. Okay, so what is the first problem? Hole in unilateral tolerances. Okay, so we're going to write this formula out here. Okay, so the hole is equal to the design size or the basic size D, and then let's see the tolerances. The hole tolerances are positive, so we can have TH up here, and the hole will not get any smaller than the design size. Okay, so now that I have this formula, there's some unknowns here, mainly this tolerance of the hole, and D will just get from up here. Okay, so tolerance of the hole is equal to this formula right up here, hole tolerance. So it's 0.008 cube root D. 0.0008 times the cube root of D. Okay, so it should be easy enough to find out. So 0.0008 cube root of 1.5000 here. Okay, so let's pull up the trusty calculator to figure this out. So 0.0, well, I'm a bit unfamiliar with this calculator, to be honest, but I think it works like this. If I do 1.5 and then I press this button right here, x to the y, and I set y as 1/3, it's the same as the cube root, I get 1.1447, and then I'm going to multiply that by the 0.0008. Okay, so I get 0.0009 and 91577. Okay, but in the question, it only wanted me to use 4 decimal places. These 4 right here. So this is less than 5, so I'm actually just going to round down so we can get rid of that there. And the tolerance of the hole is 0.0009. Okay, I'll put a box around that because that's important. Okay, so now I'm going to, fill this in. So the diameter is 1.5000 plus 0.0009 minus nothing, 0.0000. Okay, so this is my final answer for the hole diameter. So I'll put a box around that too. Okay. So now, question B says I need to find the shaft in unilateral tolerances. Okay, so B. So I know that the shaft has got to be smaller than the hole. So the formula is going to work out like this. So D, this is the basic size, minus the allowance. And I'm not going to add any tolerances to this. So that'll be held at 0, but I will be able to get slightly smaller. And I know it's negative because this table helps me out as well. So the shaft tolerance is a negative value here. So I'll just put tolerance of the shaft right there. Okay, so I don't know A, the allowance, and I don't know the tolerance at the moment, but let's start working those out. So A is equal to, let's just check out the formula here. So 0.0009 cube root of d squared. 0.0009 times the cube root of d squared. Okay, let's see if we can get this calculator to work. So d squared is 1.5 inches squared. Okay, and then I'm going to take this 2.25 value and cube root it. So I can use this x to the y function here, and I'll just do 1/3, put that in brackets. Okay, so I get this 1.31 number, and I'm going to multiply that by 0.0009. Okay, so 0.001179. So 0.001179. Okay. So I can only keep, remember, I can only keep 4 decimal places. So I may as well do that now. And so this one's above 5, so I'm going to actually round it into this number here, and my allowance becomes 0.0012. So that's my allowance. And now let's work out the shaft tolerance. So the shaft tolerance is actually the same formula as the hole tolerance, except there's a negative applied to it. So I'm just going to write that down. So the shaft tolerance is equal to the hole tolerance, or the negative hole tolerance. So I'll add in that negative up there. Okay, and so I've already calculated the hole tolerance. So I'm just going to type that in, negative 0.0009. Okay, so I'll put a box around that one, and I may as well put a box around this one, you know, to make sure I get credit for the work that I do. And then now I'm on pretty good standing to you know, answer this question up above right here. Okay, so I'm going to have to do a little bit of addition and subtraction, so I'm going to just maybe rewrite it down below. So the shaft tolerance, or the shaft diameter, is equal to 1.5000 minus the allowance, which is 0.0012, and that's going to have a tolerance of plus 0 minus 0.0009. Okay, so I guess we just need to do a little bit of math here. So maybe I'll just do it to the side here. So I can't take away anything. 0 minus 2, I can't take anything away from it. 0, so I'm going to have to borrow all the way to this 5 here. So that becomes a 4. That one would become a 9. That one would become a 9. And then finally I have a 10 here that I can work with. So a 10 minus 2 is 8. 9 minus 1 is also 8. Okay, 9 minus 0 is 9. 4 minus 0 is 4. And 1 minus 0 is 1. So get a design size of 4, 9, 8, 8 plus nothing minus 0.0009. Okay, and I'll put a box around that one too, because that is now a completed answer for question B. Now it says to look at this minimum clearance and the maximum clearance. Okay, so I think this one works well if we have a picture to look at here. So C is going to be figure out the minimum clearance. I'll just paste this picture in once again. And let's just take a look at this. So the minimum clearance is going to occur when the hole size is the smallest. I'm just focusing, maybe I'll just get rid of these ones here too because they're not important for this demonstration. Okay, I like that. Okay, so the minimum clearance occurs at the maximum material condition. So that's when the hole size is the smallest and the shaft size is the largest. So that's going to be max, that's an S for shaft, and then the hole size right here is the smallest. So I'll say diameter of the hole min. Okay, and then that becomes this little space in between the two. Which is the minimum clearance. Okay, so I think now that we have a visual here, we can write a formula for this value pretty easily. So the minimum clearance is going to equal the diameter of the hole minimum minus the diameter of the shaft maximum. Okay, and so the minimum hole diameter, if we now the orange here is tolerance. So the hole gets a little bit larger, but no smaller than the design size of the hole, and the shaft gets a little bit smaller, but no larger than the design size of the shaft. Okay, so the smallest hole size is in fact 1.5000. 0.5000, and the largest hole is 1.4988. 1.498. Now you're going to see a familiar number here when I do the math. 1.500 minus 1.498. So 10 minus 8 is 2, 9 minus 8 is 1, 9 minus 9 is 0, 4 minus 4 is 0, 1 minus 1 is 0. So the minimum clearance is 0.0012. And that's a familiar number because it is in fact the allowance. Okay, so if you just wanted to, take a shortcut, you could just, justify this formula right here. And then, put a box around it. Or if you wanted to leave it here, that's just fine. But it's a good way to double check, because if you do end up getting a different answer, then you know you've made an error somewhere in your math or the logistics of your formulas. So it's a good way to double check as well. Okay, so let's figure out the maximum clearance now. Oh boy. I'll just get rid of those squiggles. Having a little bit of technical difficulty with my pen. Okay, so the maximum clearance, I'm just going to copy in that photo again because it's such a nice visual for this demonstration. Okay, so we'll get rid of these transition and interference fits and just focus in on the clearance. Now, the maximum clearance is going to occur for the smallest shaft. So that's going to be diameter of the shaft minimum, and the largest hole. So that's going to be diameter of the hole maximum. Okay, so we can, write a formula for this now, and that's going to get us the maximum clearance, which is this value. And again, highlighted in orange here is the tolerance. Okay, so the maximum clearance is equal to the diameter of the hole max minus the diameter of the shaft minimum. Okay, so let's figure out what these numbers are. Okay, so the maximum hole size is the design size plus the tolerance. So let's write that down. So for the hole, 1.5900, 1.5000 plus 0.0009 minus, I'll put this one in brackets, and I'll put the other one in brackets just to distinguish where the numbers came from. Okay, so we have the shaft design size minus the tolerance to get the smallest shaft size. So 1.4988 minus 0.0009. Okay, so let's figure this one out. So we have, I'll just speed things up with my calculator here. So 1.5000 minus 0.0009. That's equal to, plus. I made a mistake here. 1.5000 plus 0.0009. So that's 1.500009 minus, put in brackets here, 1.4988 minus 0.0009 end bracket, and the answer is 0.0003. But I need to keep this fourth decimal place. I don't want to drop my decimals. So we'll put a box around that, and then that is our maximum clearance. Okay, so that is, how you answer a question of this type and size the shaft diameter and the hole diameter with tolerances using the ANSI recommended allowances and tolerances for a basic hole system. I hope you enjoyed. If you have any comments or suggestions in the for me, make sure you do so in the comment section below.